This week's Agents and Actions, hosted by SmythOS. Today, you've got your host, me, Amber Graner, and our presenter, Alaa-eddine. Alaa-eddine, you're our VP of Engineering, and you're going to talk today about how to contribute to SmythOS, going through our project repos. Right? You're gonna be doing all of that for us, and I've put together a little slide here. So if you're following along, it's also in the calendar invite. So if you're following along, you should have gotten these links. Go to github.com and go over our SmythOS repo. I think Alaa-eddine's going to be spending a lot of time in that repo. I've also included some helpful links that will help you get started after the after the webinar, so you can continue the learning process and getting started. Did I miss any links here, Alaa-eddine, or are we good with
I think we are good, and if anything is missing, I will share it with you. But yeah, these are the main links that we will be covering today.
All right, today, and folks, for you who are joining, you're in the webinar. I'm going to take a look here at the participants here in a minute. If you are adding a note taker, just a little bit of a housekeeping slide, that note taker will be removed because we don't know what you're going to do with that information, and people are on the screen. People could share. We want to make sure that their information is safe as well. So please don't add a note taker because it will be removed. If you do have questions during this presentation, please raise your hand. We'll unmute you, let you talk, or you can type it in the chat. Or for those of you who are watching on the live stream, you can add your comments there. We'll be watching that as well. Again, thanks for joining today. And with that, Alaa-eddine, I'm going to stop sharing. I'm going to turn my camera off, and I'm going to give the floor to you.
Yeah, thank you, Amber, and welcome everyone. I want to make this webinar dynamic. So if you have any questions, you can type in the chat, and I will try to read it and cover it during my presentation. So first of all, I want to start by talking about the repo, because we want to cover contributions and the use of SmythOS as well. So in this session, we will not cover the SmythOS Studio part. So we will not cover the visual agent building. If we have some time at the end, I can make a quick example, but this will be covered next week with Docker presentation, where we will show you how to install SmythOS locally if you want to, if you have questions about this, and we will do some demonstrations. Here we will mainly cover the core system of SmythOS, which we call Smyth Runtime Environment, the repo, the examples. I will show you how to get started as a developer who want to build with SmythOS, and also how to get started as a developer who want to contribute to SmythOS. I will cover the SmythOS architecture, so you understand how we build SmythOS and why we build it like this. And we can answer your questions during or after the presentation. So first of all, we open sourced SmythOS about 3 months ago, I think, or 4 months ago. And yay, today we hit the 1K stars, which is like a very good milestone given the short time we had to get there. And this is the main package, the main repo of SmythOS. So it's a mono repo. So we have 3 packages here in the structure. We have the CLI, which is the command line that helps you run local agents from that you built with the Visual Builder in your command line, or it also helps you create SDK projects with SmythOS. We have the core package. This is where the SRE, the Smyth Runtime Environment, really live. And we have the SDK. The SDK is kind of a layer on top of the SRE that abstracts all the complexity of SRE and expose it in a very simple API that you can use to build your agents. So to get started as a developer, the easiest way, as we explain here in the README file, we have a quick start section. The easiest way is to install the Smyth CLI. After installing the Smyth CLI, you will get this SRE create command. I will share a terminal window and I will show you an example. Let me just prepare it so we can cover this part first, and then we will move to pure contributions. Here. And I move to here. I'm sorry, I'm having some lags with Zoom when I use Zoom with Windows sharing. Do you see my terminal window?
I don't see your terminal window yet. I still see the read.
Oh, okay. It didn't switch. Yeah, one moment. Do you see it?
Yes, we see it now.
Okay, I will just zoom here so you can, it will be easier for you to see. So here, as I said, the easiest way to get started using SmythOS as a developer to build your agent is to install the CLI, and you can install it with this command, SmythOS/CLI. I already installed it in my computer, and when it's installed, you can run it with SRE. So SRE command comes with three options. So the agent is to run .smith files. These are the files that are created with our visual builder and exported so you can run them locally. You can run them in the visual builder on your computer. You can run them on our SaaS, and you can also export them and run them locally. The second option is the create command that allows you to easily scaffold an SDK project in your computer. And this is what I will show you here. And the third one is update. This checks and updates the CLI for you. So let's start with SRE create. When you run this command, you will have this screen that will guide you step by step in configuring a new project. So here I will call my project just like my agent. And here you will get some questions depending on whether it's the first time that you are running the SRE or you already have configured it previously. You will have more or less questions or steps. So here it asks for confirmation to create a folder, and then the SRE comes with 3 or 4 templates pre-configured. We will be adding more. You can select anyone here. Like I will use this third one, chat with one agent. And then here it will be asking you where you will be storing Smith resources. So this folder can be placed in your user directory or under the root of your project. And for advanced usage, you can also place it in a custom place. But to get started, just choose one of these locations. This will configure many things for you, so you don't have to care about the details. And once you are familiar with the SDK, you can use custom locations. So here I will be just using this location. And once you run this, your project is ready. And there is one important information. SRE informs you about a vault file that it creates. The vault file is initially empty, and if you edit it, you will find entries for multiple LLMs where you can place your API keys so that your agent can use these LLMs. So in order to run your agent, this example agent, if I remember correctly, uses OpenAI. You need to have an API key placed here in this vault file. So now that our project is ready, I will just go to the agent folder. And then I will run npm I to install it. Then I will build it and run it. So as I said, you have 4 templates from the simplest to the more complex. We will take a quick look to the code and how it looks like, and then we will go in some examples from the repo to explain few things and how Smith SDK makes it very easy to build agents for developers. So the installation is done. Now we can build our package. The build is done, and now we can go ahead and start the agent. So this is a chat agent in a terminal. So I can chat with my agent, and I will show you how the code is implemented in a few minutes. So you can see it's this agent will use an open API to get informations about books. So for example, I can say like, give me details about the book. Let's say The Great Gatsby. Okay, I can say like, what is the ISBN of the book before? We can see here some tool call happening because it's querying the API, and then it gets the information and so forth. So I will stop the demonstration here, and now I will open the source code to show you in a high level how this looks like. I will need to switch my sharing again. Give me a second. So this is the project that we created. You can see here we have the source folder. You have the index file. The index file have a lot of comments to guide you through your first implementation in SmythOS. The most important part is the agent that we have here. So here is how an agent in SmythOS looks like. I'm importing agent class from the SDK and few other classes that I need for my code. And basically an agent is an instance of agent class plus skills. So you can see here that I created an agent. I'm using this GPT-4o model to run my agent. The behavior is the system prompt. And then I can add skills where I declare how the agent works. So here I'm creating few skills. So the first one, it allows me to index PDF files in a vector database. And second one is the lookup for a book. And this is what I used in my demonstration. This will use an API call, or like this one. This one will use an API call in openlibrary.org API to search information about the book. And I also have a lookup skill that will query my vector database about the previously indexed data. And that's it. Like an agent is basically agent declaration plus skills. I will cover how to query agents using the repo example, so you can find this information when you need it. I just want to highlight here an important thing. So this method of implementing agents is how you implement it in a SDK. So when you are running in SDK, you will like to run a custom code that will implement the agent skills. But I mentioned earlier Visual Builder that allows you to build agents with drag and drop. These kind of agents will create what we call a .smith file. A .smith file is a symbolic representation of workflows that can be also run in the SDK, but this time, instead of creating an agent, you would do something like this, like agent.import, and here you will import your .smith file. Like my agent.smith. Usually you would do something like this. And again, you can either use this agent.smith will also have its own skills that you built in the Visual Builder, but you can augment with the SDK and add custom skills or dynamic skills. Now, what the SDK offers you are many abstractions to, for example, parse documents, insert data in vector databases, query data from vector databases, store data on storages, and so forth. I will go back to the repo now. Give me a second. I'm switching again to the repo. So this is how you use SmythOS to build agents as a developer. In this repo, you have this examples folder where you have many examples from the simplest to the more complex. The examples covers pretty much everything that you would need to get started. For example, I will are also important. It's somehow we try to keep this order from simple to more complex, like and also to separate the to simplify the learning curve. So here, for example, you will focus on agent skills. Here you will focus on how to import a Smith file, how to run workflows, how to implement vector databases, and so forth. So we'll start with the agent skills. And I will take the first example. This is a very simple example that just explained to you how to create a simple agent. Like I said earlier, we have the, I'm creating my agent. I'm adding just one skill, and then I'm prompting my agent and capturing the result. Okay, so this is a very simple case. Now, some of the capabilities of SmythOS is, let me show you here. So here, for example, we are prompting our agent and we are waiting for the results. This means that the agent will try to answer this question either from its own knowledge or by using the skill. And you will need to wait for the agent to generate the full response before you get the answer. Now, let's say you want to handle this with streaming. You know, all modern chat, AI chat applications handle streaming. In SmythOS, the streaming, moving from this prompt to streaming is extremely simple. I will move to example number 2, and you will see how it's done. So again, I have an agent, I have skills, and now for streaming, I will call the same command, my agent.prompt, and to this .prompt, I will add .stream. From there, the result will no more be waiting for the full response to come. Instead, it will return an event listener, and in this event listener, I can listen for incoming content, errors, tool calls, and so forth. And this allows me to build extremely good user experience because I can stream my responses, I can tell the user what's going on, and so forth. So you see that the same command with just a tiny change can completely change the behavior of the way you prompt agent. And the whole architecture of SmythOS works like this. We try to keep things extremely simple so that you focus on agent building rather than trying to figure out how to do things. Another important example, I will show you how to turn an agent into an MCP in SmythOS. So in this example, again, I have my agent, I have my skills, I have here I'm describing what this input is. Like I can give clear description for my my LLM. And now I want to expose this agent to MCP. Well, I call agent.mcp and I'm done. This is an MCP server. So you can see in one command, you are turning your agent into an MCP. There is no other framework out there that makes it so simple. We can take other examples. Yeah, it also has like a chat framework that already handles the conversation memory, everything for you, and it works the same way as an agent. So the difference between prompting an agent and chatting with an agent is the conversation memory. When you are prompting an agent, you expect an answer, but then if you prompt again, the agent completely forgets the answer. This has some use cases, and it's valid for many use cases. But if you are implementing a true chat application, you would call agent.chat. This will give you an object, right? And from this object, you, again, just like an agent, you can either prompt it or prompt it and add .stream, and you have a stream. Very simple. So you can see that as a developer, if you want to use SmythOS to build agents, it makes your life very easy. There are examples here for vector databases, storage, and so forth. You can go through all these examples. I will just show you like a shortcut to get everything you need, or pretty much everything you need to get started. Here in our README file, we have documentation for SDK, SRE, and code examples. So you can click here in the SDK documentation, and you have like many sections here that explain most of what I said in details. But we have this cheat sheet that you can check here. And this gives you like code snippets for pretty much, I think it can cover 80% of what you would like to build with your agent. From like create agent, add code skills, handle streaming, chat with agent, MCP, LLMs, and so forth, right? Now, this is valid for you if you are a developer who want to build agent. Now, if you want to contribute to SmythOS, well, first of all, you will need to clone this repo, and then you will, since this is a monorepo, we are using pnpm package manager to build and release our repo. So you need to clone this repo, run pnpm install to install the dependencies, and then pnpm build to build the repo. Once you do that, you can navigate to your examples. For example, if you are using VS Code or Cursor, these examples folder come with a pre-configured launch file for debugging. So if you want to run any example in this folder, once you have built your project, you can go here and you open your source code and hit F5, and it will run the example in debug mode. So you can go step by step in the code and see how the SRE works. Now, for developers, you will need to understand the SRE architecture. Before I go deeply in the code, I will show you, I will give you a high-level view of how we built the Smith runtime. I will switch my screen again, sorry, because we have a lot of materials to share here. So first of all, why do we call SmythOS an? Because usually this term is overhyped, like we call anything operating system. And here I'm showing you the architecture of the most famous open source operating system out there, Linux kernel. So Linux kernel architecture looks like this. You have like virtual file system with drivers and so forth, and you have subsystems. So for example, here we have the memory subsystem, the process subsystem, and so forth. And below, this is the architecture of Smith runtime. It is not built on like native code. It is built on top of Node.js, but you can see the similarities. We also have these subsystems, and each subsystem has services, and each service have implementations. An implementation is what we call a connector, and this is what gives the SRE the interface to the outside world. For example, for vector database, we have bindcon connector, we have MilVis connector, we are implementing Postgres connector, and all these connectors share the same interface. So it doesn't matter which vector database you want to use, it will always have the same interface in the SRE. And it works like a driver for an operating system. Same for storage, same for all other connectors. Now, why does this matter? It matters because it makes your connectors swappable. So when you are developing agents, the SDK will use very simple connectors and local services to run all your agents. For example, for the vector database, it will run an in-memory vector database. So it requires zero setup. For storage, it will use your local storage and will store data in your user folder. For cache, it will use your RAM again, and so forth. So it will use all local resources. So you need zero setup to get started. Now you implement your agent and you are happy with your code and you want to deploy it to production. In this case, with Smith Runtime, it requires zero change or almost zero change in your logic, because what you will need to do is configure SRE to now use custom connectors instead of the default one. For example, instead of using the RAM vector database, you will use Pinecone or MilVis. Instead of using local storage, you would use S3. Instead of using JSON vault file, you will use AWS Secret Manager. And this requires no change in your agent code base. It's all handled by connectors. Also, when we want to extend Smith capabilities, all we have to do is adding new connectors. So this is the power of this architecture. And we borrowed it from operating systems because we believe that AI agents are basically applications or comparable to applications running on operating system. And in order to run apps properly and handle their resources properly, you need an operating system for them. So we created the operating system for AI agents. I will go to another screen here and I will show you clearly, like this is a different way of seeing SmythOS. So for example, I will start with this one. So basically, you can see the Smith runtime, the SRE, as the kernel, right? This is the low-level part. The Smith SDK, what I presented and how you build agent it with code and so forth as the syscalls or libraries. So this is the interface between the kernel and your applications. And on top of it, you have many things. You have Smith Studio, which is our visual builder. We have the CLI. This is the application that I showed you that allows you to either run agents or create SDKs. And we have our SaaS. This is the commercial version of the visual builder. And on top of all of this, we have agents, which are the equivalent of your apps in your operating system. This gives us full flexibility in distribution, security, and so forth. So, for example, a typical SaaS architecture using this terminology would look like this. We have the SmythOS runtime. On top of it, we wrap it inside a Smith server so we can expose APIs to our visual builder, to embodiments. Embodiments are a terminology that we use to talk about everything that exposes an agent. So for example, a chat interface is an embodiment. A voice interaction is an embodiment. An agent that runs in Microsoft Teams is an embodiment, and so forth. And in the bottom layer, we have these databases, cache, storage, security, vector DB, and so forth. This is the layer that is handled by our connectors. And in the case of a SaaS product, we will have usually a middleware that closes this gap. This is cool. We can build agents with this. Now, let's say I don't want to run them on a SaaS and they don't want to run them locally. Well, we can run them on AWS. because it's always the same kernel that handles how to run an agent. But in the bottom layer, we have AWS adapter, which means for storage, I will use S3. For key management, I will use Secret Manager. For caching, I will use Elastic Cache, and so forth. And on the top of it, I can choose either to expose APIs or have a dashboard and so forth. This is up to my implementation. But at the end of the day, on the top here, I will run agents. Again, another possibility is our CLI. So we have a CLI adapter. Again, we have the Smith runtime kernel. On top of it, I can have a CLI interface and a user interface. But on top of it, I will always have agents. This is why we talk about this operating system terminology. And this is how SRE solves this problem. Another important thing that we did in our architecture, you see here a global access right manager, and here we have a security subsystem. So every connector that runs here has full security check and isolation. This means that, for example, if you are running two agents and they are both using storage, but these agents belongs to two different teams, or you are just running two different agents by default without putting them in teams. Even if you use the same names for your storage files, for example, every agent has its own kind of sandboxed storage. It can never overlap this storage or exceed it or read information that does not belong to him. So this data isolation is applied at every level of SmythOS. So the developer does not have to care about security and data isolation. If you want agent to share data, you need to put them in the same team and explicitly say that a data is shareable. We can go and cover this probably in a dedicated meeting webinar to security, but just so you know that this is also handled by default. Now let's get back to the repo now that we covered the principles, and I will show how this translates in the code structure. So in the code structure, I will go back to the packages, right? We have the SDK package. We will not cover it here. What interests us is the core package. So in my core package source, I have this subsystems folder. And in the subsystems, I can find all the subsystems that I showed you in the architecture view. So we have input-output systems, we have LLMs, we have memory, we have security, and so forth. So if I go to I/O, I have multiple services. I have a storage, for example, VectorDB, router, NKV, and so forth. Let's take a look at vector database, for example. Here in vector database, I have multiple connectors. They all inherit from this base class. So I have Milvus connector, Pinecone connector, Ramvec connector, and we will be implementing more. And our community is already contributing with some connectors that are being tested and will be added soon. So for example, if you are interested in contributing to SmythOS, the easiest way or the simplest thing to start with is implementing connectors that does not exist. And we encourage you to use vibe coding, by the way. The only thing that we would like you to do if you contribute if you vibe code and use AI to create these connectors is to test it. Like, don't just generate code and assume it is working. We want you to test it. We have unit tests here. You can adapt them quickly to match your new implementation and run the unit test to test it. But at the end of the day, all the connectors structure are similar. if I go, so you remember here, I want inside a service, so vector DB, I have a base class, I have connectors, and inside the connectors, I have the different implementations. If I go to storage, I will have the same structure. So again, a main connector class, connectors, and inside connectors, I have my different connectors. I will go to another service, let's say memory, cache service. Again, I have the main connector class, and inside the connectors, I have Redis cache, S3 cache, RAM cache, and so forth. So the good thing about this structure is once you know how to build a connector, you can build all connectors for SmythOS. And this is also important, especially for, like, for example, security connectors. Here we have an account manager, right? So SmythOS comes with, by default, the SDK will be running this dummy account connector. And if you want, you can switch to a JSON account connector. Our community studio, the visual builder, has a custom connector here to handle your accounts. But for example, if you want to integrate SmythOS with your own architecture, you want to use our kernel, but in, like, let's say in your product, well, you can handle account management by implementing a custom connector here. Basically, an account connector is a way for Smith Runtime to know the agents, the users, and the teams, and the relationships between them. So agents and agents belongs to users, and users belongs to teams. Basically, this is the architecture. From there, Smith Runtime is completely agnostic. So you can implement this with, let's say, an authentication system, and you verify tokens before accepting that this user belongs to this team. You can query the users from a database. You can query them from different source of information, and so forth. So this is about the connectors. We also have a concept. I will not go in details for it until we cover the visual builder probably next week, but we also have the concept of components. So the components are the small pieces that you can use to build a workflow in the visual builder. And again, all components are here, and you can implement custom components. We will write specific documentation for this part. It's still not ready because we need to prepare a documentation to show how to work with the visual builder code and the Smith Runtime code side by side, because typically a component is a code that runs in the Smith Runtime and a visual representation that shows the component behavior in the visual builder. So this will be probably covered in next webinar sessions. Another thing, or another way to contribute, is to check the issues. So usually when we see simple issues, we tag them with this good first issue. Like, let's take a look at this one. So we create this issue. So this one was already taken by someone, and I think it's fixed, and it will be merged in the next few days. But usually you can find here some issues that you can grab and take a look. And if you feel comfortable of implementing them, you can go ahead and implement, and then you can follow, the standard flow. You make a pull request. We will review it. We will tell you if you need to revisit it or make changes. And if it's accepted, it will get merged first to our development branch and then released with the next iteration in the main branch. So this is an overview of Repo. We covered Smith Runtime. We covered the security, the architecture. I didn't check. I didn't see if there are questions. So I will stop sharing for a moment, and maybe we can take some questions. And yeah.
Thanks, Alaa-eddine. I'm not seeing any questions yet, but if anyone has any that we haven't answered, please feel free to drop them in chat. And Alaa-eddine, you kind of touched on next week just a little bit while we're waiting on questions. It's pretty exciting. So you mentioned SmythOS Studio. What word would you like to attach to SmythOS Studio to get everybody kind of excited about it? Or words, I guess, if you want to put
Oh,
it
yeah. Well, yeah. And here I will take this segue to cover some questions that.
It looks like we got a hand raised. Hold on one second. Let me unmute you, and then we can get back to that topic, because I want you to set it up for why people should really pay attention to next week's. Give me just 1 second to Chima. All right, you're live. You can talk to us. Go ahead and ask your question.
All right. Thank you, Eddine. I hope I got your name correctly. Alaa-eddine. Thank you for that wonderful class.
Yeah.
Can you hear me?
Yes.
Yes, we can. Go ahead.
Okay, so this is Chima calling from Nigeria. I've joined the platform for a while and I've been trying my hands on your platform. It's really been interesting. However, I'm very new here. So I checked the repo and I saw the example folder you just started. I think having a README file at most of the folders, like inside of the example, would actually go a long way, because I tried cloning repo and trying to implement most of those folders on my end, but there was no guide. However, I just noticed that the code, they are pretty simple to understand if I had gone through. So yeah, it could make sense also adding a README folder or README file at the root of each of those examples. Thank you.
Can I ask you to, and Alaa-eddine, you might be asking this too. Can you open an issue on that, and so that we can see it, because we're here in this chat, and while we'll try to remember to go back and tell our coworkers and our peers that this was a question in the request. If you could go into that repo and open an issue on that would be great.
Yeah, if you have a GitHub account, go ahead and open an issue, and don't hesitate. There are again, I always say there is no dumb question. There is no, like, everything is important. And you pointed out something important. Maybe we did not cover the how to run examples properly. There is a README file at the root of examples folder, but maybe it does not cover everything. So if you can go ahead and open an issue ticket, I will make sure that the team take a look at it and we will address this. So yeah, to get back to the visual builder, one thing that Rick here asked before we start the live was something like, how does SmythOS compares to Copilot agent builder from Microsoft, and maybe, like, we can say globally to other agent builders. Well, first of all, we are open. Like, we want to be open and we want to collaborate. Like, in an ideal world, there will be no like one single place to build agents. You can build agents, but the most important thing is to make them interoperable. Right. So this is the ideal world, and this is what MCP is kind of trying to do, an A2A protocol. So the point of the visual builder is to give everyone the possibility to run an agent builder locally and to completely own his data. So this is very important. And unlike many other products, we decided to open SmythOS under MIT license. This is the most permissive license out there. So it means that we will never question how to use the code, how to use the builder, how if you run the Docker image on your local computer or on your server or on your company, we will not question that, right? We are here to support. We have like business offers for the ones who like want our support and like custom implementations and like hosting on our servers and so forth. But the most important thing, you own the code, you own the data, you own everything. We are making sure to give possibility to run everything locally. Like I said, the SRE was built from the ground to allow running everything locally. So when you implement when you run the Visual Builder, the first version is an alpha version, by the way, because it does not have all the features. We are rolling new updates very soon. So in the first version, you will need to have API keys from OpenAI or Anthropic or other providers in order to start running agents, right? But in next versions, we will support all Llama and LM Studio. Both will be supported. So both of them allows you to run, I think they cover 99% of all open source models. You can run pretty much everything on Llama, and the part that is not covered by Llama is covered by LM Studio. Also, LM Studio, I think for people who are not very familiar with command line and stuff, it's more user-friendly. So starting from beta version of our Visual Builder, you will be able to build your agents and run them locally without needing external LLMs. And yeah, also, it will give you a very easy way for non-developers or just for developers who do not want to build with code, a very easy way to build agents with drag and drop. And we are the only tool who allow you to debug your agent skills step by step. There is no other tool that allows you doing that. When you build your agent in SmythOS and debug it, it's like using your favorite IDE for code, but here you will be using it for agents. So you'll be able to run the connectors and components one by one, checking inputs, checking outputs, inspecting, and like if something goes wrong, you will be able to solve it with this debugger. So yeah, that's it. And I hope that we will be able to also cover some ways of building agents that save you time, because we tried many tools before building SmythOS, and we are building SmythOS for more than 2 years, by the way. We recently open sourced it. Our goal was to solve all the pain points that we encountered in other frameworks or from other building tools. And last thing, we also wanted to provide a full end-to-end ecosystem, from building agent as visual with Visual Builder, to building it as code, to running it, to deploying it, debugging it, observing it, and so forth. So one of the pain point, or maybe major pain point that we found out there, is that you need to install a framework to start developing an agent. Then you need to install a dependency to start using a vector database. Then you need to implement a security code. Then you need to install another dependency to handle storage. Then you need to install an orchestration framework to orchestrate your agent, and so forth. This is very painful. Like it's very difficult to make production agents with all this complexity. But if you have a single ecosystem that handles everything from end to end, this makes your life easier, and this is what we are aiming to.
Thank you, Alaa-eddine. Unfortunately, we're at time. We're a little bit over, so I just wanted to remind everybody, thank you for your questions. Thank you for showing up today. Thank you for those who are watching online, and for those who come and watch afterwards. We want you to get started today. And as Alaa-eddine kind of mentioned, we'll be going over our Docker image, our SmythOS Studio next week on this webinar. So we want you to take a look at the repo, start if you haven't already. Go spin up your first agent over on SmythForge if you're so inclined to do that with our free SaaS offering. You can walk through the tutorials on SmythOS Academy. Check out our docs. If you brought up a question, just like Shima did and others, and you need to file an issue, go over to GitHub, choose the SRE repo, and open that issue. Join us on Discord. Please say hi. We're starting to have monthly or bi-weekly community meetings now, so please join us over there. And don't forget, these things are stream live. And so check out our YouTube channel. And those of you who joined via the calendar invite, the live link is also in there. The links from today are in there. And I will also throw the slides, a link to the slides in the calendar invite as well. So you should be able to be invited to all future agents and actions. So thanks for joining today, and we'll see you next week. Alaa-eddine, thanks for presenting. And next week you'll be with, I guess Ahmed will be with us next week. So
Yeah.
join us next week for SmythOS Studio, and have a great day.
Thank you.